let us see how we're going to do this. If you have the root of 1 plus sine x over 1 minus sine x equal to sec x plus tan x. This is very, very simple. It's just talking about your text of identity of the trigonometric formula or trigonometric ratios. And how do you, or what do you need to do? When you take all of this, you just need to do some set of things. And let me show you how we're going to do it. So the first thing you need to do is this. When you take the root of 1 plus sine x over 1 minus sine x, first thing first, let us even forget the root now. Okay, we are going to be dealing with the roots. Let's talk about this. When you have 1 plus sine x over 1 minus sine x, one of the things you can do to actually, eliminate some biases is to either multiply the numerator or denominator by the conjugate of themselves. Do you understand? What do I mean? The conjugate of 1 plus sine x will obviously be 1 minus sine x, and the conjugate of 1 minus sine x will obviously be 1 plus sine x. You get what I'm trying to say now. So I'm going to be dealing with the denominator, okay, so as to actually work faster. So I'm going to be having 1 minus sine x. So the conjugate of 1 minus sine x will be 1 plus sine x. So I'm going to be using 1 plus sine x to multiply both the numerator and the denominator. So I'm going to be having something like 1 plus sine x multiplied by 1 plus sine x all over 1 minus sine x multiplied by 1 minus sine x. Everything will become sec x plus, okay, sorry, I don't really need that. I want to prove to the left hand side actually. So the next thing we need to do here is this. Since we have 1 plus sine x plus this, obviously the upper one is going to become square roots of 1 plus sine x all in squared. Or you get what I'm trying to say now. And then this one, if you look at these two, it looks like a difference of 2 squared. So we're going to be having something like 1 minus sine square x all in what? All in square root. Let me bring this to this side so that we can have log root. So now if we have that, we are going to be having 1 minus sine x square, all of that. So what we need to do is this. We can obviously square will cancel this square, so we're going to be having, let me draw a line here. Oh sorry, the line is not straight. Let me have it drawn. So I have, oh Jesus, it's not straight again. Let it just leave it that way. So I have okay, so now that is done. So we're going to be having something like 1 plus sine x. Alright, 1 plus sine x all over 1 minus, okay, sorry, let me, so that's not to actually cause anything there. So we're going to all over square root of 1 minus sine square x. So now if you remember something, before I actually write that, I believe, let me take you through a recall. If you recall, you know that if we have sine square x minus plus cos square x is equal to what? 1. So this simply means that 1 minus sine square x equals to what? Cos square x. So put that in mind. So that means I can just have that and put it here. So that means the whole of this can become root of cos square x. You get what I'm trying to say now. So obviously now we can now say this square will actually cancel this square. So we're going to be having something like 1 plus sine x. As you can see, it's all coming together now. All over what? Cos x. So lastly, the last step in this, don't mind my line, it's not straight, I know. At least don't worry, I'm improving, come on. So 1 plus sine x over cos x. So tentatively that will become 1 plus sine x, 1 plus sine x. So what we're going to do now, I can just dissociate this and be like 1 over cos x plus sine x over what? Over cos x. And if you recall that 1 over cos x is equal to what? Sec x, which is this. And then 1 over, sine sine x over cos x equals what? Tan x, which is what? Which is this. So we can just write and be like, so therefore we're going to be having 1 over cos x, that will be sec x plus tan x is equal to sec x plus tan x. So this is proved. Okay, so that's how it is done. All right, so if you have any question, let us see in the next video.